Hello, welcome to Algorithms. My name is Raveen. I'll be the convener of Comp 3121/9101 Algorithm Design and Analysis. I'm joined by two of our course admins.
I'm Song.
I'm Liam.
So, we will be teaching you all about the wonderful world of algorithms. To give you an idea of why we want to study algorithms, I think we've all been there in terms of solving computing problems and reading a problem, writing some code, and finding out that it doesn't work. And then trying to apply patches to make it work. And this turns out to often be a harder process than we think, right? You'll write some code, write a test case for it, and see that it's wrong. So you go and dig into why exactly that bug happened, fix that, etc., etc. Next thing you know, okay, now it's too slow. Why is it too slow? And this whole process can be a little bit of a rabbit hole. Instead, we're going to try and teach you how to plan the process of problem solving so that you can set out a method by which your program is going to solve this problem before you actually go and deal with the nitty-gritty details of how exactly this works, right? What implementation choices you're going to make, all this kind of thing, right? So we're going to teach you a structured approach to problem solving using various algorithm design techniques that we'll talk about later. Why are we studying algorithms? It's so that we have this structured way of thinking about problems, breaking down the requirements of a problem, planning things in a way that's independent of programming languages, implementation choices, hardware, etc., and thinking about things on a more abstract level. We also need to be able to communicate those ideas to other people and present our work in a way that's well-reasoned and thorough, in a way that we can work in teams and delegate work to others.
So the course content will follow directly from Comp 2521 or 9024, which is data structures and algorithms. We've introduced a new prerequisite this year, which is Math 1081 or Comp
9020.
9020, thank you.
So that is discrete maths or foundations of computer science for the postgrad students?
Yep, and that we thought was important just to give everyone a basic overview of how we want to set out writing and how we want to go about discussing algorithms.
We just want to ensure that what you get out of this course is you are able to justify your algorithms, argue them well and correctly. You also want to make them as efficient as possible and perhaps along the way learn a few new tricks for your in your toolbox, such as typesetting in LaTeX, for example.
Yeah, exactly. So our learning outcomes are that you can understand how famous algorithms solve problems, that you can solve problems using the same ideas that underpin those famous algorithms, that you can reason about why your algorithms are correct and why they're efficient, that you can communicate about those ideas with other people in writing, and that you can present your work in LaTeX, which is also very useful for those of you who might go on to write a thesis. And so along with that, this is the exciting part of the video because I get to tell you about all the new things that we're doing this term. So this course is going to run very differently to how it's run previously because a lot of the assessment is changing. Along with rewriting the learning outcomes, we've taken a very close look at how exactly is our assessment measuring whether you've met those outcomes and how best we can help you to achieve those outcomes and perform well in those assessments. Previously we've had assignments which you'd go off and do on your own. We'd help you with practice problems, but fundamentally all of your assessed work would be stuff that you do by yourself. And with a relatively slow feedback cycle, we're now replacing that with a single portfolio assessment, which is made up of lots of little tasks that you'll do over the course of the term. So you'll have many small tasks which ask you to do a quiz on Moodle, write a sentence, write a paragraph, occasionally write one page of where you put it all together. But and all those tasks will be marked not by the void, but by a person who you see every week who is your lab demonstrator. So this course now has labs where you'll go in and work on your portfolio tasks during the lab time, get some immediate feedback from a person who you can put a name and face to, and all of these portfolio tasks are formative in nature, meaning that you can work on them, submit what you've got, get some feedback, and fix it until it's done, right? So we're no longer marking things, we're just telling you this is done, or this is what you need to fix in order for it to be done. And we hope that this will take a lot of the pressure out of learning algorithms. The accumulation of all the work that you do on these portfolio tasks is your portfolio, and that is the largest assessment. That is 60% of your course grade. Within that, as we said, there are lots of tasks, but you don't have to do all of them. If you are, this is going to work on a basis of what we call contract grading. So you select what grade you're aiming for, what letter grade, pass, credit, distinction, high distinction, and the higher grade you want to do, you have to do, if you want to achieve a high grade, you have to do all the tasks up to that grade. So every task has a designation as being a credit task or a distinction task, and only students aiming for that grade or higher need to do that task. So if you're here to get a pass, that's completely fine. We're going to run you through all the fundamentals that you need to demonstrate to us that you understand everything. You're everything that's at a basic level. We're happy to pass you on as having met the outcomes of the course. But if you want to extend yourself and push for a distinction, high distinction, then you'll be faced with all of those tasks, but also some extra tasks where you're asked to problem solve and do more creative work. And more synthesizing different levels of ideas and processes. But we'll have lots more details about that and the platform and how to complete these tasks as we go. But just to give you an idea of, we're trying to take a lot of the stress out of in-term assessment and help you along the way, giving you both guidance for while you're doing those tasks and feedback quickly on when you've done those tasks and how you've done. Yeah. At the end of all that, there is of course an exam, and that exam makes up the remaining 40%. There is a hurdle on that exam because that's the one time that we can test you on your own in like a kind of controlled environment. So you do need to achieve like a 40% mark in the exam just to show us that yes, you can do everything on your own. Up until that point, collaboration is totally fine and encouraged. As long as you submit something that is basically your own work. But of course, by the end of that process, we hope we've given you all the support that you need in order to be able to show off to us in the exam that everything that you know and can do now.
Yep, so on top of all those assessment changes, we have labs for the first time this term. So each of you will be assigned a 2-hour lab slot. We have lab demonstrators in them who you will get feedback from about your assessment tasks. They're there to really guide you, point you in the right direction, mark tasks off as done for you, and so on. So hopefully that will be very valuable. On top of this, we still have the normal scheduled tutorial, which is a 1-hour slot. Tutorials this term are also a little bit different. They're going to be larger classes, and we have 2 different streams running. Which one you attend is completely up to you, and you can attend both if you like. So the 2 streams are tortoise and hare. In the tortoise tutorials, the tutors will go over 1 or 2 select problems and really focus on underlying concepts behind those problems. They'll move a little bit more slowly and really just aim to reinforce concepts. In the hare tutorials, the tutors will be going through a much larger variety of questions, and the aim is on problem solving. So you'll see how concepts can be applied to a wider variety of problems, which may help you with your labs, but both are going to be great.
The course content by and large remains the same. So we'll walk through sort of introductory problems that provide a bridge from your prerequisite courses. So these commonly include things like, how do I use binary search, or how do I just tweak it slightly to solve a completely different problem? And then we'll walk you through sort of new concepts like greedy, max flow, DP, and divide and conquer, which all have their own sort of strengths and weaknesses. So divide and conquer just attempts to break problems down, as the name aptly suggests. Greedy is kind of also it's very self-suggestive, but it does adopt a very human way of thinking. It's just what if I was just greedy? What if I just wanted to eat all the cake, for example? Max flow is a very different type of paradigm because it requires you to operate on. It requires you to focus more on modeling the problem rather than picking apart the problem and constructing a solution. But it works with sort of networks rather than a variety of data structures. Dynamic programming is more of a thing where you take smaller steps towards a globally optimal solution, but it shares similarities with greedy, and in some cases will underperform or outperform greedy. And lastly, we look at intractability, which is more of a bridge to further algorithm courses that you may want to look at, such as Comp 6741, Comp 4121, and Comp 4128.
And 4141.
And 4141, yeah.
All of that might seem a little bit intimidating, but fear not, you have plenty of support throughout the course. You've got your tutors, you've got your lab demonstrators. We'll also have the Ed Forum, which has been wildly successful in the past, where you can ask questions, and we have a dedicated team of forum moderators who will be monitoring that every single day to try to answer as many of those things as possible.
And you'll also get to know your fellow students on the forum, and
Yep.
we often have a lot of students who are really generous with their time and build their own understanding by helping others.
Yeah, a bonus point sort of thing.
Yeah, so on that note, students who contribute to other students' learning in various classes on the forum and so on will receive a small number of bonus marks in case the kudos wasn't incentive enough, I guess. So I think that's everything from us. We are very excited for the new, relaunch of algorithms, and we look forward to you bringing your enthusiasm for the new year as well. Thank you. See you around.